So Bismillah ar-Rahman ar-Rahim, October 2021, 31 variant question number 9. What is method to solve this question? He is saying number 1, because this is a line L, this is a line M, and he's saying what in this question? He's saying that show that L and M are perpendicular. How we can show they are perpendicular? So I said before, this is called R is equal to A1 plus S time to B1. This is called a point number 1. This is called direction number 1. R is equal to, I call A2 plus T times 2 B2. This is called direction 2. This is called point 2. So I hope so clear. According to plan, if I have to prove they're perpendicular, so what I will take both directions and dot product of them must be equal to 0. So let's try to do it. So B1 dot B2, I'm going to find it. So B1 is coming from here for -1 and 3. And this one is direction is coming here -1, 2, 2. Because logically, because formula is B1 dot B2 equal to B1 magnitude, B2 magnitude into cos of theta. But if theta comes 0, so 90 degree cos 90 becomes 0. If this 0, the whole thing becomes 0. So if the right part is 0, so naturally it means it's called they are perpendicular. So let's see how we can get it perpendicular. So let's see. So corresponding position values will multiply like this. And let's see what answer returned to be -4, -2, and +6. And if I check it, I got a 0. So it means we can say that hence L and M are perpendicular. Shortcut writing of perpendicular. So let's talk about the part number 2, B part. He said show that L and M intersect. So let's try do it. And whenever we talk about a point line intersection, so we prove that 90 degree. So where they cut, that is called point of intersection. So whenever we talk about point of intersection of two lines, so student, what to do? So I will convert line L in its standard form. So let's start. So standard forms of both lines I'm going to find. So what is the method to do? I coefficient 3 and I coefficient is 4s. So I'm getting here 3 from here and 4s from here. Repeat. J coefficient is 2 and s multiply inside -s. So 2 -s. Here k is 5 and s multiply inside. So I get what here? 5 plus 3s. Let me recheck. 3 plus 4s, 2 minus s, and 5. Yeah, correct. Let's talk about second one. Second one, without explanation, I'm writing directly -t and 1 from here. So I am writing 1 minus t. And same way, -1 plus 2t, last -2 plus 2t. Now I got this two line, okay, is line standard form, and I have to find the point of intersection. So if they are intersect, they are equals to each other. So R equals to R. So I will get these equations. When I'll put R equals to R, I will get this kind of thing. So best idea, save my time. Save my time. How I can save my time? I just take this equation, copy, paste. And then I take other equation, copy, and paste. Okay. And I got this one. So I will get a 3 equations. So this and this equals to each other. So I get a 3 plus 4s equals to 1 minus t. Reshape. Okay. I bring t on the other side. I get a 4s plus t. And 3 goes on other side. I got a -2, equation number 1. Now J coefficients I take now. So 2 minus s equal to -1 plus 2t. So because I'm writing s before, so I bring s here to make it s positive. So s positive 2t, and this -1 goes there, becomes 3. Equation 2 done. Now same way k coefficient. So I believe nothing hard. Alhamdulillah Rabbil Alameen. 3s minus 2t is equals to -7. Equation number 3. Now what to do, student? I will take any two equation to solve. Any two, sorry. Any two equation, I will take it. I think this is easy to solve. So I'm solving 2 plus 3. So I copy these two equations and I paste here. Okay. So when I solve it, this cancel out. I got a 4s. Here I got -4. So s becomes -1. And this value of s, I cannot put in 1. I will plug in either 2 or 3. Reason because I'm using 2, 3. So I will keep one equation untouched. Okay. Just for checking purpose, which I will do later. Okay. So this s value I will copy here, put in 2, -1 plus 2t equal to 3. 2t is equal to 4 and t becomes 2. Both values I will put in equation number 1. So both values I'm putting there. So 4 times 2s and t equals to -2. -4 plus 2 equal to -2. And they match. If they match, so it's proved they intersect. So
Sir, we can only check with the equation we did not touch. We can't check with
exactly,
the other
exactly.
ones.
Yeah, I'm worried about it. Maybe it creates some issue sometime. So better is best technique. Don't touch one equation, use there only. So though they intersect.
Okay,
So
sir.
they intersect. They intersect. So Alhamdulillah Rabbil Alameen, this part is very, very clear. Let's talk about the last, but he said, no, find out a position of that. So I have a two choices. Either I will plug in S value here, or I will plug in T value there. So both are any choice, anyone. So I'm writing now, it is called point position vector of intersection. So of intersection. I label as a only R. Okay, I think I plug in this positive values. Okay, I plug in there. So 1 minus 2, when I plug in 2 here, I got a 1 minus 2 become -1. Okay. Then I plug in, okay, 2. I'm putting 2 here. Best idea. When I plug in 2 here, I got -1. When I 2 to the 4, I got a 3. 2 to the 4, out of 4, 2 gone, I got a 2. Let me recheck. 4. Yeah. So this is my final answer. Cut from here and I paste here. And this is my final answer. So Alhamdulillah Rabbil Alameen. Now I talk about the last part, and that is C part. So C part is a very tricky 4 marks. He said, show that length of perpendicular from the origin is this. So it means line M he talk about. So I will take line M only. Okay, so I just show idea. This is origin. So 0, 0, 0. And line is here. So this is a perpendicular goes on the line line M. And this is called F. F stand for foot of perpendicular. And perpendicular means 90 degree for sure. Whenever he asks for length of perpendicular, I will find out OF length later on. But first of all, I need foot of perpendicular. Now, how we can do it and have a look now. This planning, I'm going to start. Wait a minute. First, I bring the diagram down. Okay, this is a planning. So let's see how we can fulfill the plan. So let's start. First of all, this line M, you know it very well. This is a line M. So line M, I will write it here and I will write its standard form of line M. So what is the logic? I'll tell later. And luckily line M standard form is available here, which I am copy paste from here and copy and bring it down. So this I am writing now here. This is wait a minute. Okay, paste here. So this is line M. Now you may ask one question. So why you convert standard form? I discussed many times when a line converts standard form, it represents every point lie on the line M, every point. So this I can represent the F. So this becomes OF. OF1 minus T, -1 plus 2T, -2 plus 2T. Okay, now planning is what? Because 90-degree student, you know it very well. I discussed even the first part. Whenever they are perpendicular, dot product must be equals to 0. And that planning I can use even here. But thing is that what is this vector, student? This is called OF vector dot. What is this called? Line direction B2 is equals to 0. From where I got B2 line direction. And if you look at, go back and see here. So this is called B2. This is called line direction of line M. I will take this part only. And this is called as a B2. So I hope so got a point. So let's, what is direction? -1, 2, 2. -1, 2, 2. So -1, 2, 2. So -1, 2, 2 is this, but this is a B2. Now only thing left OF. And where is OF? I believe it's nothing hard. OF, luckily I have it here. So I will plug in it there. And now I'm starting the rest plan. So rest plan, I'm shifting here. Okay, and OF I get from the top here. So right, so 1 minus t, -1 plus 2t, -2 plus 2t. And dot product, you know, corresponding positions multiply. So -1 into both values, I get -1 plus t, -2 plus 4t, and -4 plus 4t is equals to 0. 4 plus 4, 8 plus 1, 90. 4 to 6, 6 and 1, 7. So I got a 7, and I got 7 on the other side. So t becomes 7 by 9. So let me recheck again. So I got a 2 to the 4. This is a, yes, exactly correct. Now it means that this t value at this particular point is 7 by 9. I repeat, maybe t value here different, here different, here different, here different, here different. But at this particular point, the t value is becoming with us is 7 by 9. I believe this point is very, very clear. And now we can complete it. How we can complete, student, now? Because he said not to find put a perpendicular. He said find the distance. So have a read, please. Length of the perpendicular from origin. So short story, we are looking for this distance. This distance. For that reason, I need F coordinates. How to find F coordinates, friends? Plug in t back in this. So let's find it. So let's try. So I'm finding OF now. How to find OF now? Be careful. This value will go there. So I will take my calculator, chance of mistake. When I plug in this value here, so 1 minus 7 over 9 give you 2 by 9. Same way, this value will go here. So I'm getting -1 and plus 2 times to 7 over 9. I'm getting 5 over 9. So this value go here now, and value is coming -2 plus 2 times to 7 divided by 9. I get -4 over 9. So student, now this is a very clear. So this is OF. If I find a distance, so how to find distance, students? Not a hard job. I'm going to complete it here. Wait a minute. Okay, so I'm going to complete it. How to find distance? So modulus is called distance. Okay, so now we may ask one question. Wait and watch. Let me finish, then I come to the point. I squared every value. I squared every value. So let's see what answer turned to be. Okay, here I got a 4 over 81. Here I got 25 over 81. Here I got 16 over 81. Okay, let me simplify. If I add 4 plus 25 plus 16, I got 45 over 81. If I take a root of the whole thing and I take the root of this, it tends to be, I think what is the answer demanded? 5 over root 3. Correct answer. And we got even same here. So root 5 over 3, or you can write 1 over 3 root 5. So alhamdulillah rabbil alameen. You may ask one question. So why we not apply distance formula? Correct. Even apply this -0 whole square, but distance formula is what? If you remember, student, distance formula is x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. Even I apply that one. So look at here. This minus this whole square remain same. Okay. So if I say this minus this whole square remain same, and last one, this minus this whole square remain same. And I hope so. Concept is very clear, and question is completely